Theosophical Society and its guests. We're very happy this evening to have Gordon Plummer present a slide presentation called In the Nature of Things. And this is going to be used in his upcoming tour in Europe. So at this time, I'd like to turn over the program to Gordon. And thank you, Gordon, very much for coming.
Thank you, Robert.
And we certainly will appreciate your words.
Thank you. Well, needless to say, it is a great pleasure and a privilege to be talking with you folks today. And I'll start right in by saying that there are two aspects to this demonstration. One is the descriptive, in which I will be participating throughout, and the other is more subtle. It is a kind of what we might call an inner life of mathematics. The mathematics that will be shown are extremely simple. No one need be the least bit afraid of mathematical formulas and the like. But its beauty is in its simplicity. And it deals with a wonderful aspect of mathematics with comparatively little industrial value, except in architecture and art, and known as the golden section, and Plato and Pythagoras spoke of it as the divine proportion. Mathematically, you will come to see what it is as the slides proceed. And some of the things are so remarkable to be shown, all within that aspect of mathematics, the golden section, that you might ask, well, how did this come about? Were there divine beings that ordered this? That is not the answer. The only answer is in the title of the talk, In the Nature of Things. This is a beautiful picture of the Andromeda, often called the nebula, but it's the Andromeda galaxy, really, very similar to our own, composed of billions of stars, with, of course, planets, moons, no doubt, cosmic dust, meteors, anything that we have, maybe even theosophists, you never know. This is a picture in Yosemite National Park. Now, the reason for showing these two is not directly related to the golden section, but it is a call for an understanding of what our sense of beauty is. Our sense of beauty, it seems to me, is a kind of a recognition of something that defies expression in words, but it's something that we feel, which is part of the inner life of the universe. Now, this is the first slide, and it shows the apparently two circles. Now, we're going to start from the beginning by telling you not to think of it as two circles, but as a circle in motion to the right. And we're going to imagine that we have measured this, and for our European friends, I'm holding to the metric system in discussing these. So this circle is deemed to be 1 meter in diameter, 100 centimeters. And the distance from A to A is equal to the diameter. And we'll imagine that a wheel, perhaps someone on a unicycle, is riding along here, and he passes over the point A, which we had marked, he moves on and stops at point A prime. And being a friend of ours, he's very obliging in this respect. Well, then we have a tape in the metric measure, and with it we had already ascertained that the diameter is 1 meter. Well, in measuring this, we discovered it is 61.8 centimeters, a very remarkable thing, because 61.8 is to 100 as 0.618 is to 1. There you have a simple statement of the golden section. And this line from A to the far circumference, C prime, is divided at a remarkable point at C, where it enters the circumference of the circle, or the moving wheel. The distance A to C, 0.618, has the relation to C prime 1. the same as C to C prime, or 1, has to the whole line 1.618. And these are three numbers never to be forgotten. They are reciprocals. 0.618 is the reciprocal of 1.618. And this, of course, is the midline, we might say. And we're going to find that these three numbers only, with them, we can construct a five-pointed star. Now here on a line, we have established the points 1 and 2. We're going to simply call that 1. Not necessarily 1 meter or a yard or an inch, but just 1. Now, we set our compass to 1.618 and draw an arc. From point 1, then from point 2, we draw another arc. The arcs intersect at a point we call 3. We join 1 and 3, 2 and 3. We have a very remarkable triangle. We're going to learn much more about that triangle. And we have here the base stands to the side of the triangle as the golden section. Here is the five-pointed star somewhat expanded. And we have the upper point of the star expanded into a star in its own right. At the base we have a small star, and then there is an inverted star in the center. This is just the beginning of an interesting series which will be shown more fully in just a moment. But the smallest line is to the next as 0.618, to the next as 0.618 to 1, to the next as 0.618 to 1, to the next as 0.6, and so on and so on. But you're going to see that that is going to be greatly amplified. Now here we have the light lines against a dark background, so it will show up much more clearly. We recognize what we saw just a few moments ago, and the pentagon is completed. We have actually 12 stars here, and from the smallest line that you can find to the next larger and so on, it is continually a repetition of 0.618 to 1. Every time you see a five-pointed star, a five-petaled flower, a starfish, anything with five sides is an expression in nature of the golden section. It may not be perfect as a drawing, but the principle is there nevertheless. And this becomes a beautiful expression of the nature of man as we're studying in our theosophical work, the various monads in man, you can interpret it, or the various sacred planets. You can interpret it in any way you like. And it is worth saying just at this moment, I don't treat these things as symbols of something, because then you can use your own imagination as to what it would be a symbol of. But rather, these are expressions of something. And we recognize what they are as we learn more and more of the ancient wisdom. We don't have to invent reasons for this, but we discover that all that you're going to see this evening is in the nature of a statement of certain principles underlying nature as we perceive it with our senses. A little bit like simply a chemical symbol, H2O. We know that produces water. Water is there. The H2O is a statement of it. And every time you combine elements just like that, it will always be water. So that's the view that I take of all that is coming now. Now here we have this greatly expanded. This is virtually what you had seen, but now all in color, and we have it expanded in the center. And this reminds me very much of the old Greek legend of Atlas holding the heavens upon his shoulders. In some versions it's the earth. I like the version, the heavens, the universe on his shoulder, Atlas with his arms out, his head, part of the universe. nothing separate at all. You cannot separate even an atom from the universe. You'd have nowhere to put it. And so this is a beautiful statement of a principle that each one of us is actually part of the universe in all of its complexity. Now in this one, the head of Atlas has been expanded in the same way, which then again allows us to make a statement that the nature of man is identical in principle to the nature of the universe as a whole. And we could say that this, in that sense, could represent to our imagination a man who is so illumined that to him that is a reality. He sees it as a real thing, that he is a pattern of what created the whole of the universe, or how it came to be. Now it is expanded only one more time, but this could be carried on to infinity. And the stars would become greater in number and smaller, and by the 10th, 12th, 13th expansion, they would be all perhaps about the size of atoms. But nevertheless, everything that is right about this would be right about the smallest of the stars, which could itself be expanded. So this can suggest to our minds the meaning of the teaching, that all things are composite, and that every entity is one of hosts of like entities forming a greater one, and that that small entity of itself is composed of still smaller entities, of which it is, you might call, the hierarch, the chief of that system. It can go on endlessly. And so this also, if you like to use your imagination and think of this as the man who has achieved a high degree of initiation to the point that his consciousness is actually universal. So you see, there are various avenues of thought in which we can go when we see something of this nature, and it is all mathematically accurate. Now we come back to that moving circle, but something has been added. This distance from A to C has been divided exactly in half. And with that as a radius, an arc has been drawn, cutting the circumference of the circle. This distance and 2 of the radii forms one of those wonderful triangles that we saw only a few moments ago. And that line steps exactly 10 times around the circumference of the circle, so that you have 10 of these wonderful golden section triangles. And now we should analyze. The angle at the base of each is 36 degrees, is 72 degrees at each base angle and 36 degrees at the center. Those numbers will become more apparent soon. And we are about to analyze just one of these golden section triangles. Well, actually, we are going to discover there is more than one, and we'll come into that. Here is the triangle just as we had seen it in that circle, the 10 triangles. And this angle at the left hand at the base being 72 degrees, it is bisected by a line which touches the opposite side at the point of the golden section. Now, we have 36 degrees on each side here. Something very remarkable happens because we're going to bisect the right-hand angle at the base with a line, which again makes a golden section point of the line just previously drawn. We have a new triangle. The 2 base angles each of 36 degrees, the apex 108 degrees. Now these 2 triangles are drawn here, and they were held so sacred by the ancient Greek mathematicians and mystics, Pythagoras and Plato. They were given names, the names of the 2 bright stars in the constellation of Gemini, the twins, castor, and pollux. So this is the castor triangle, we shall know, and this is the pollux triangle. In this case, we find that on a base which is common to both of them, the castor triangle, the original, and the pollux triangle on the same base, a curve has been drawn. And with the point here as the center, the curve across the common base. But by bisecting these lines, we have another pollux triangle, part of a curve, another part of the curve, another part, and that could go on endlessly. And we have here a nautilus shell, a section of a nautilus shell. And here is one of the most famous, the best known examples of the golden section in nature, because this can be held at such a point, we may have to look for it for a moment, but it can be held at the point where it exactly fits that curve. And it is a beautiful thing to discover. And I hope I have held it just right for as far as it goes. It's a wonderful thing that it is built on this golden section curve. And the little creature who built that didn't know that, of course. It's in the nature of things. And this is a particularly interesting curve. It is known as a logarithmic spiral. It grows larger very rapidly, and after only a few turns, it is too large to draw. And it is also known as an equiangular spiral simply because from the eye, any line coming to the curve is always the angle exactly the same as all the other lines. Now that's the only hardest part of mathematics you're going to get this evening. Now we have turned the whole thing vertically, and we find a new statement. And please understand, nothing in this demonstration is invented. You cannot invent any of this, you can only discover. And so I have simply placed it vertically instead of horizontally and drawn a circle here. This, at least to my mind, in the light of what we have learned, is a statement of the coming into being of the universe or of any project that we may undertake. So instead of taking technical terms, we'll use simple English words. In order to produce anything, it may be a house, it may be a railroad, it may be a watch, it may be anything. There are three essentials. There's the need, there's the plan, there's the work. And I think that if we analyze anything that we undertake, there must be the need for it, there must be the plan, then the work. Now, still using English words, we have more technical words in terms of the universe. We have, for the need, we call it the unmanifest. For the plan, we call it the partially manifest. For the work, we call it the manifested universe. The same thing in principle. And it makes some of those, a statement like this makes some of those very difficult and recondite teachings not so difficult after all. Just the simple thing, and it isn't then three circles, it is the circle in motion. Or, if you like, the first circle becoming the second, becoming the third, because the three essentials are really one, the three in one. And this matter of the three in one is going to become very important to us in a short while. Now, something wonderful is going to happen in this circle, but before we accomplish it, this shows two of the 5 regular polyhedrons. Now, the names are Greek. The word polyhedron means poly, many, hedron, face. And here are 2 polyhedrons because each of them has many faces, different shapes, certainly. And this one has a Greek name, icosahedron. Icosa means 20. It has 20 faces. This is a dodecahedron. You'll see a better view of it later. A dodecahedron, dodeca means 12. It has 12 faces. Here the faces are pentagons. In the icosahedron, the faces are triangles. But there's a wonderful relationship between these two figures. They are a matched pair because each is constructed of 30 lines. And while the icosahedron has 20 faces and 12 points or vertices, the dodecahedron has 12 faces and 20 points. They are a matched pair. But more than that, they are reciprocals of one another. Because if you can imagine, you can crawl inside this icosahedron, and that you could see inside it certain lines from the various points to all the other points. All of the points are radiating lines among themselves. Those lines cross in the center of the figure as a dodecahedron. If you could crawl into that dodecahedron, you would also see all those lines inside. In that case, 30 of them intersecting to form a small icosahedron. In that sense, they are reciprocals of one another. And if you look inside that icosahedron, you'd find a smaller dodecahedron, then a smaller icosahedron, a smaller dodecahedron, until finally no bigger than an atom. But that's only the beginning. It goes on forever. And then you could extend the edges outward until they meet in 12 points in space. Join those points, you'd have a surrounding dodecahedron. Extend the edges of that, they would meet in points in space, you would have another icosahedron. That would be repeated infinitely, larger and larger, infinitesimally smaller and smaller. So each one is what we might call a constructed model, but in the nature of things, hypothetically, they are surrounded by ever larger ones or within ever smaller ones. So in that sense, they are reciprocals. They are unique in that sense. So now we come to this. Every point has been joined with all the other points. In the nature of things, you have an icosahedron drawn enclosing a dodecahedron in red, formed by the lines that we just imagined as within the figure. Now I have this interesting thing to show. This is a constructed icosahedron with a dodecahedron at the center. And if I hold this in the light so that a point is toward the source of light, its shadow is exactly the drawing that we have. Exactly the same, if I'm holding it just correctly and still. And that is a very remarkable thing if you, from the distance, can see that shadow. It's identical to the drawing. Therefore, a new concept comes into all of this. This representing a shadow, the shadow is only an appearance. This is the real thing. Therefore, instead of thinking this as a circle, think of it as a sphere in motion. And that the sphere in motion, when it has moved a distance of its own diameter, it has generated as a mathematical concept, nothing that you see, but a mathematical concept. It has generated this figure, an icosahedron enclosing a dodecahedron. And you can say then, every star in motion, every planet in motion, or with us, a basketball thrown or a baseball, that in motion is continually generating only as a mathematical idea, which becomes interesting once you know about it, generating a figure like this. And this is only the beginning. Now we have two more of the geometrical figures to show, a cube and an octahedron. The cube and the octahedron, again, are a matched pair, but they are not reciprocals. They are matched in the sense each has 12 edges. The cube has 6 faces and 8 points. The octahedron has 8 faces and 6 points. They are a matched pair in that sense, each with 12 edges. But you could not crawl inside the cube and find another octahedron being formed. So the dodecahedron and icosahedron are unique in this respect, and you're going to learn after a while how unique they are. Now in this, to make the picture of the interlacing tetrahedrons more real, we have some of these on display for you to look at later. We have folded the cube out into the form of a cross on the table. In the center represents, or is, the picture of the model of 2 tetrahedrons. And why 2? Each of the other figures had a matched pair. The tetrahedron has itself as the match, because each one consists of 6 lines. Each one has 4 faces and 4 points. The only match would have 4 faces and 4 points. So the 2 interblend, making the solid form of what is often known as the Star of David, the interlacing triangles. And it is prominent in the seal of the Theosophical Society in its own interpretation of the union of spirit and matter. And this could be taken as a very interesting statement, if you like, or a glimpse into the meaning of one of the greatest initiations, where the number of degrees in the cube, 6 squares, the total number of degrees is 2,160. You're going to see a picture soon showing all of that. And in one particular very great initiation in which the Buddhas, the Christs, are born, so to say, it is occurring once in 2,160 years. Just the same number of years as there are degrees in the cube. And this then could represent the dual nature of man, spirit and matter. The lines shown in yellow, which are merely the intersections of the faces, are the edges of the octahedron in the center. It's all a very wonderful statement of inner facts of being, which we come to learn more about, not by taking these as symbols, but as studying the teachings. We suddenly discover the teachings are revealed in the golden section, once we know them and can recognize them where we find them. Now here on a table, we have all of these figures set out in a certain order, and above them are the various elements of the figures. We won't take time going through all of them, except that one part of this is of very great interest. The value of the numbers 3, 4, and 5. Starting at the center, we have the tetrahedron, the triangular pyramid. We have the octahedron. This has 3 faces around each vertex. The octahedron has 4 faces around each vertex. The icosahedron has 5 triangular faces around each vertex. If you place 6 triangles around a vertex, all you have is a flat surface. Taking in this direction, the 3, 4, and 5, it's 3 triangles, 3 squares, 3 pentagons around each vertex. Put 3 hexagons around each vertex, you have a flat surface. This proves that all of the geometrical regular polyhedron are represented. There are 5 and 5 only. Now there's something very interesting about the number of degrees in these figures. We did touch on the cube. 3 plus 4 plus 5 equals 12. 3 times 4 times 5 equals 60. 12 times 60 equals 72. Each one of these geometrical figures is built, is 720. Each one of these is built on that remarkable figure 720. And just to give it as simply as I can, in the tetrahedron it's 1 times 720. In the Octahedron, it is 2 times 720. In the cube, it is 3 times 720. In the icosahedron, 5 times 720. The dodecahedron, 9 times 720. That 720 works all through in a most fascinating way, and it all works in the cycles of the zodiac. A little bit too much to go into at this time, and there will be other talks, of course, on the trip on the zodiac, but this figure 720 is very, very interesting. Now here is what I call an open structure, because you can see right through it. It isn't constructed as in the slide previously shown. You have the cube in red. You have 2 diagonals in green across each face of the cube. They form the interlacing tetrahedrons. Lines joining the centers of the faces all form the octahedron. And all of this is found on the dodecahedron. The icosahedron brings the dodecahedron into being. It is on the dodecahedron, as you will soon learn, that these figures are constructed. Here is a constructed figure just like the one that I showed you, although this is more complete. Icosahedron enclosing the dodecahedron in blue. You can see the lines joining the points interiorly of the icosahedron. The red line across each face of the dodecahedron is an edge of the cube, and the green lines crossing are the edges of the interlacing tetrahedrons, the octahedron in the center in yellow. So all of that figure then is constructed simply by a moving sphere. Now here is a drawing in the hexagonal view of just what we've been talking about. And it's listed here, the icosahedron, the dodecahedron, the cube, the tetrahedrons, and the octahedron. Now, taking this geometrical figure that we had previously held with the point toward the source of light, we're now going to have merely a face toward the center of light, and it forms a picture that you see right there. The shadow is identical, if it's held exactly right, is identical to the drawing of this figure, which now we call the lesser maze. The lesser maze is the construction of this figure. Now we have a picture of very great interest, and again relating to this geometrical figure. And I'll start by saying that at a concert, there was a fine symphony orchestra, which is the mainstay of the concert itself, but many of the numbers do not require the entire orchestra. There may be a piano recital, there may be a trio or quartet and so forth. Well, here we have an example that is somewhat similar. Not all of the figures are represented here. And the 3 that we are going to touch on now are the icosahedron, the dodecahedron, and the octahedron only. The cube that you do see there in red will be left to another purpose in only a few minutes. Just now we'll consider the icosahedron, the dodecahedron, and the octahedron. This forms a most remarkable statement of what is meant by the Trinity. How can a thing be 3 and 1 at the same time? 3 persons in one, and yet one. And I'll explain what I mean. Now, first of all, the icosahedron formed the dodecahedron by joining internally the lines, and the lines crossed, forming the dodecahedron with the pentagonal faces. You can see the pentagons. Now, I showed you only a few minutes ago that the octahedron is formed by joining the midpoints of the faces on the cube. That is perfectly correct, perfectly true. But there's much more to it that you're going to discover. Exactly the same octahedron can be formed without the cube at all. But by joining 12 of the points on the icosahedron, there are 20 of them, but by joining 12 of them to the 12 points of the dodecahedron, they combine and form an octahedron. Now that is a very wonderful thing, because the three now, as you see, can be related from what we've learned, and using the terms most familiar in the West, the Father, the Mother, the Son, a Trinity. And how much do people understand what is meant by the Trinity when they say the Father, the Mother, the Son, or different ways which formed the various church backgrounds and so on? Think of the icosahedron as representing the cosmic Father. Think of the dodecahedron, because it holds the cube and the tetrahedrons and also the octahedron, as was shown. It would relate to the Mother, and the octahedron as the union of the Father and the Mother becomes the Son. And what human being is not formed by the union of the Father and the Mother? And it is a universal principle. And so here you have a most remarkable statement of the three, although they are separate figures, and with their own names, their own numbers of degrees, nevertheless, they combine to form a trinity. And this is one of the most beautiful lessons that this study has to teach us. This is a drawing of it. The icosahedron, the dodecahedron in lighter lines, the octahedron shaded to bring it out. Every one of the lines of the octahedron meets at one end the dodecahedron, at the other end the icosahedron. And if we think then of spirit and matter, the human being, as an example, is a combination of spirit and matter. And every single line of the octahedron is of itself born of spirit and matter. So in that sense, this is a beautiful lesson which is brought to us, which means more to us because we've studied about the Trinity in the more technical teachings, the unmanifest, the partially manifest, the fully manifest. But you have only to go to the Secret Doctrine and other prominent books. You find the Sanskrit names for all of these. Now here we have the icosahedron, the dodecahedron, and the cube. Another trio taken out of the orchestra, as it were. Here we have a mathematical trinity. Do you remember those very, very important numbers at the beginning of the talk, 0.618, 1, and 1.618? You have that right here. If we assign to the edge of the cube 1, just unity, 1, the edge of the dodecahedron is 0.618. The edge of the icosahedron is 1.618. And then here is a table of numbers, probably not well seen. We find that the series, the 0.618 getting smaller, the 1.618 getting larger in the one that you hold in your hand, gives rise in the hypothetical, if you like, the imaginary, or choose a word for yourselves, the figures that you can't see, but they are there. Within this one, there's a whole series of them mathematically going down infinity, a whole series going outward to infinity. But is there a relationship between the lengths of those hypothetical figures with this? There certainly is. Here is a table, and these three numbers represent the constructed figure that we have. And the cube 1, icosahedron 1.618, and the dodecahedron 0.618. And on the previous slide, the first hypothetical one was drawn, and the one in the center too small to actually be seen. But now we have, as the icosahedrons are expanded in the way that we were describing, extending the edges and meeting in points, forming another dodecahedron, extending them, another icosahedron. Because all of this is in logarithmic progression, we'll explain that in a moment, the expansion becomes tremendous in a very few moves. So now in this table, we have, I'll just name it serially, the cube, the icosahedron edge, the dodecahedron edge, the cube, icosahedron, dodecahedron, and so it would go on forever, larger and larger, and the cube, the dodecahedron, the icosahedron within, the cube, the next dodecahedron, the numbers getting smaller and smaller in value. Now, where is this a trinity? In the most remarkable way. This is a series of numbers without changing any of the numbers at all. Has the properties of three separate series of numbers that you study separately in mathematics. The arithmetic series, because it increases by addition. Any term is the sum of the two previous terms. Wherever you find it, any term is the sum of the two previous ones. That's equally true, however smaller in value the terms go. And of course, the opposite of addition is subtraction. Any term, the difference between any term gives you the next one. The difference between those gives this. The difference between those gives that. So it's an arithmetic series. It is what is called a geometric series because it increases by multiplication. Any term multiplied by 1.618 gives you the next term. Wherever you are in the series, any term at all multiplied by 1.618 will give you the next. Going downwards, any term multiplied by 0.618 gives you the next term lower. So it increases by multiplication as well as addition. It increases exponentially. Here I'm using a word that seems to be strange to you, but the exponent of a number is just the small number that is written to the right of the number and a little above. That's a superscript. And 4 squared would be 4 with a little 2. That is called the exponent. And numbers increase very rapidly as the exponents increase. Taking the easiest example, simply 2. 2 squared is 4, 2 cubed is 8, cubed to the 4th power is 16, 2 to the next 32, 64, 128, 256, 512, 1024. You can see how rapidly it increases. Exactly that happens here. So we have a very, very interesting view of some of the deeper teachings. And I will explain first about this. This is a root number, And these represent, starting from the center, the 0 power of any number is 1, which in itself is interesting. It doesn't matter what number you choose. Its 0 power is always 1. All right, then, the first power is the number itself. Squared, it is this number. Cubed, it is this. To the 4th power, and so on. It increases. There are negative powers. And each of these numbers is a positive power of 1.6, but a negative power of 0.618. A negative power is simply this. The negative power is the positive power of the reciprocal. Now, let's see if I can say that again. These are reciprocal numbers. They increase as you go up the exponents, but they decrease in size as their powers increase. It makes smaller and smaller numbers, but we'll leave it at there because only those familiar with mathematics will appreciate that, and I'm not going to make the talk tiresome, but actually in going into this it becomes more and more interesting. Now here's a remarkable thing. Let us take this that we hold in our hand, and just for the sake of argument, we're calling this 1, the cube, the value of 1. Let's suppose it's a foot. Let's suppose I made a large one, which actually I have at home, and the length of the cube would be 1. And we'll call each of these an expansion. By the time you have expanded this only 12 times, that outer hypothetical one would more than include the whole Earth. So only 12 expansions, it becomes larger than the Earth. Now in those two golden triangles that we saw, we called Castor and Pollux. There was the one with 36 degrees as each base angle, 108 at the apex. That is a signpost in the very process of expanding these. We're going to expand it 36 times only, and 36 is not a very big number. But by so expanding it, only the 12th time, it is larger than the Earth. By the time you come up to about 16, it would encompass the moon's orbit. Then we would have to change our stance. Instead of standing on the Earth, we would have to imagine ourselves in the sun, at the center of the sun, and seeing the whole solar system spread out before us. After only about the 20th expansion, this, hypothetically, would have expanded to include the entire solar system. And we talked about 36 expansions. Well, we'll have to change our stance now to the center of the galaxy. By the time you've expanded it only 36 times, what was the number of degrees at the apex? It was 108. You would have raised 1.618 to the 108th power. This would be large enough to more than include the whole galaxy. Now that is what is meant by exponential expansion or logarithmic expansion. It expands at a continually greater rate as you go along. And to think that only 36 of these surrounding this one would enclose our entire galaxy. Now that, to me in my own work here, appeals to me very much as a statement of the various monads in man. Our vital astrophysical monad is confined to the Earth. The higher human monad is confined to our globe chain. A wider range of consciousness. The spiritual monad has as its range of consciousness the whole solar system, where we took the stance in the center of the sun. All of that very, very meaningful in this study. And then eventually the divine monad is related to the galaxy as a whole. There you have a beautiful statement of what we learn in our deepest teachings about the expansions of consciousness in the various monads, and all of them forming the one entity that we're calling a human being. And we're mostly conscious just on a certain level, but the widest range of consciousness, the inner God, is a reality. It isn't a far off imaginary concept. It is as real as we are real here in this room. Then we can relate it also as a statement of the experiences after death. the marvelous experiences. The lower vital astrophysical is discarded right on this globe D, and the higher human makes its peregrinations throughout the entire globe chain. The spiritual monad makes its peregrinations through the entire solar system, and that's why we have the sacred planets. And only that is part of the story. We could spend evenings on that one theme. But the spiritual monad, of which we are the children, while we are asleep in the after-death state, makes its marvelous journey through the sacred planets. Then in the highest of the initiations, the initiant goes out and does this consciously, not in an after-death state, but with full knowledge of what he is doing. And finally, the highest initiation of all, entering one's own parent star. His own divine monad is the ray of his own parent star. Again, another wonderful story. The range of consciousness is the galaxy. So you see, that's why I say a thing like this is a statement of certain deeply esoteric teachings. And it's all there. Now here I said that I would relate it to the solar system. I did bring this out in the mathematics of the cosmic mind. And I did not include the table of what I might call the golden numbers in this, all part of the system we're talking about. But I was able to conceive, we might say, a pattern relating to the actual distances and years of the planets as they go around the sun, not in the numbers that recognized by astronomy. And I should bring that out clearly. No astronomer would go along with this unless he had studied the esoteric teachings. But an example of what I mean by nature is regularly irregular. The easiest one to understand is that related to the Earth. And there you have the occult number 360. So important. There's 9 times 40. And you have there a divergence from that. Everyone knows it's 365 and a quarter days. Therefore, a scheme like this would not stand up at all to the scrutiny of modern astronomy. But it can be of great interest to students of the esoteric tradition, as we all are. And so taking what I felt was the pattern number. In all of this, we're looking for the pattern. And taking the pattern number of the various planets, not written here, but relating the planets 2 by 2, I get a proportion which reduces to a number to 1. And for instance, Mercury to the Earth 4 to 1. That means that the year of Mercury is approximately 4 times the year of the Earth. Now there's a proportion that I mean. In the case of the Earth and Jupiter, you have the number 12. The Earth does make somewhat more than 11 circles around the Sun to one of Jupiter, but the occult number, nevertheless, in what we've been able to build up here, is 12 to 1. All of these numbers relate directly to the faces and the vertices, the edges of these 5 regular polyhedrons. So I present this for your consideration, but please don't tell them at Mount Wilson that I've done this. Now we come to a very interesting part of the study. It's really part 2. We see a dodecahedron here, and we see certain red lines which appear to be a square. Each face is crossed by one of the lines. Now the point is that they really form a cube. And if you have one line in a pentagon, why not have 5 lines making a star? Wouldn't that make sense? If you do that in every face, instead of 1 cube, how many cubes would you have? Exactly, 5. Thanks for telling me. So there is a sort of an outlined picture of the dodecahedron with a 5-pointed star in each face. And here then you have actually a drawing of 5 interlacing cubes. And in some instances when this talk is given, we have a model. And as I'm talking to you here in Long Beach, we have a model constructed for you all to look at of 5 cubes, all interblended, and with each cube of a different color. Well, here is a picture of the constructed model of the 5 cubes. And the white one is quite easily recognizable, and the yellow one, they are all interblending, and there are actually 12 5-pointed stars. Wherever you see a 5-pointed star, each line on the star is of a different color, because each of the 5 cubes contributes one of its edges to a star. And that is how all 12 stars are formed. The only real one of wood is the green one. And then I made plastic models, all designed on the golden section, and fastened them to the 6 cubes and then colored them to the 6 faces, and we have the interlacing cubes. So there is as constructed, and here it is as drawn. There's the drawing of the 5 cubes. Well, if you have 5 cubes, you can have 5 octahedrons. Why not? So there are, as constructed, the 5 octahedrons, each of a different color, and this is something of very great interest. There are 12 places on this figure where the lines seem to meet in almost a little valley, all 5 of them. There are 12 of those. Those points are exactly the same points of the inner icosahedron formed by joining the icosahedron to the dodecahedron, making the icosahedron inside. That little icosahedron touches every one of the edges of all 5 cubes at those points. And furthermore, it touches each edge of the octahedron at the point of the golden section. How did that happen? In the nature of things. But that is one of the most marvelous aspects of this whole structure. Everything fits. And actually, we all fit into the universe. So then this is the drawing of the 5 octahedrons all blended together. And you see such a point right there, and the lines coming. Well, that's here we see 5 tetrahedrons all blended together. And these are made of cardboard, and they seem to have a sort of a turning effect, don't they? But pairs of tetrahedrons. And in the next slide, we may have it. It is the mirror image of the first one, and it is the other 5. I was not able to construct that. That was just a little bit beyond my ability, although I knew in my mind what it should be. And I did make a drawing of it. So this is the drawing of 5 pairs of tetrahedrons all blended together. And so this accounts for all of the regular polyhedrons. In the full construction, all 5 within the dodecahedron. Now here is a drawing in the 10-sided or decagon view of what I call then the greater maze. The lesser maze has 1 cube, 1 octahedron, 1 pair of tetrahedrons. This has 5 of each of all of those. And within the decagon, now that amplifies the picture that we had when we had the need, the plan, and the work. And then there was that picture of the icosahedron, which we then expanded into really being a solid figure within the spheres. Now, all of this would be within a moving sphere. the greater maze hypothetically. As it moves, every time within space where it has moved a distance of its own diameter, all of that would be within that sphere. Now here you have all of that in the hexagonal view. And I might say that if you had a point there, there, and there, you'd have all of this within the tetractys. There again is another story. And then in the book by the Holy Tetractys, I expand on that very considerably. Here then you have the picture of the complete greater maze. And it is the icosahedron, the dodecahedron. You soon lose track of the identity of the figures in there, but I actually do have this at home and constructed, and then it makes a very beautiful figure. And then this is the last one, and I wanted to have this one partly because if you see the shadow, these figures give shadows in depth. And wherever you go, every shadow seems to be perfectly flat on the ground. Virtually so even the trees. But a figure like this, if you're spinning it, that shadow spins. It's a most beautiful thing to see. Then the last thing that I also wanted to bring out is that I wanted the people who see this to feel I am a part of their evening, and I thank all of you for your attention.